Okay, let's talk about average values in AP Calculus. So to find an average value from A to B, for example, you're going to have to use this formula right here, which is 1 over B minus A, crowbar, B at the top, A at the bottom, f of x dx. So, for example, let's take a look at this thing right over here. Right there. Okay. So, we have this graph right here, f of x, and we have to find the average value of the interval from -4 to 8. So if we go from -4 and we count up all the areas, and that'll be what we have right here. And then for the 1 over b minus a, we're going to do 8 minus -4, which is going to be positive 4. So 8 plus 4 is 12. So you have 1 over 12 times 6 minus 11 plus 10, right? Because remember, if area is at the bottom, it's going to be negative. So this overall will get you 5 over 12. Now let's talk about just like assuming without calculating. Take a look at this one right here. The average value of this is negative because there's way more negative area, like area under the line being shown than there is positive area, right? This is negative, this is negative, this is negative, that's negative. The only thing that's positive right here is this little nub, okay? The average rate of change is also negative because the way you find this is by just drawing a straight line from point A to point B, okay? And if that is going down, that's going to be negative. If it's going up, it's going to be positive. So let's talk about finding finding average value on a calculator. Okay, so function f is defined by f of x is equal to x squared times cosine parentheses x plus 5. What is the average value from 3 to 7 round to the nearest thousandth? So this kind of question, there's no way you're not going to have it on a calculator. Same as before, you want to do that 1 over b minus a thing, so 7 minus 3. And then you have your crowbar stuff right here. 7 at the top, 3 at the bottom. Now, f of x, it's like almost impossible to do whatever this is in your head or on paper without a calculator. But there's when you do it on the AP test, you'll be likely given a calculator on this kind of question, so you don't have to worry about that. What you want to do is press the math button, go all the way down to this one right here, or just press 9, and you have your top and your bottom of your crowbar. For us, it was 7 and 3. Now we're going to type in that equation right there. We have x squared times cosine of x plus 5. Right, and that's over, that's dx, right? So we put that in and we get a number. But remember, we have to divide it by 4 because of this thing right here. 1 over 7 minus 3. That's the same thing as 1 over 4, which is the same thing as dividing this number by 4. So we divide this number by 4, and we get 4.864, and then a bunch of leading numbers. We can round that off to get negative 4.864. Okay. Let's talk about particle motions with this whole thing. Particle travels along the x-axis such that its velocity is given by v of t is equal to t to the power of 0.8 plus 4 sine t minus 1. Position of the particle is x equals -4 when t is equal to 3.5. Determine the position, velocity, and acceleration at time equals 1. So this is going to seem like a bit of a review. There it is, there's a question. This is going to seem like a bit of a review to anyone who's done the prior units. But what you're going to be doing for this one is you're going to be taking your 1 and then your 3.5, and you're going to subtract your 3.5 from before. So you have your, you're going to plug that in. Position of the particle is x equals -4 when t is equal to 3.5. So we just put -4 here. Then we do plus crowbar 1, 3.5 v of t, and then you just put that into a calculator. You get negative 15.946. Now, This equation is already in velocity, so when we have to find the velocity at 1, we are simply just, typing that in. It's that simple. A1, however, is just a bit more difficult. We're going to do it on the calculator again. You're going to go press math. Nope, that's alpha. That's A. You're going to press math. You're going to press 8. And you have your derivative thing right here. You do d over dx is equal to, and we're going to type in the thing, except we're going to replace all the t's with x's. X to the power of 0.8 plus 4 sine x minus 1. And that's x is equal to 1, not x, right? Because we want to find it at a very specific point. So type that in, and we get 4.7999999, and we can just average that out to 4.8. So from this, we can figure out some stuff. Like, for example, because x is negative, we can figure out that it is moving away from the origin, or moving to the origin, because let me just zoom into my key right here. Your particle is moving to the origin if x of t and v of t are different signs. Your velocity is going to be, your particle is moving right if v of t is bigger than 0, left if it is less than 0. Your velocity is increasing if a of t is bigger than 0, it's decreasing if it's less than 0. And then speed, this was one that might be a bit like, you might have forgotten this one. Speed is increasing if v and t and a of t are the same sign, and speed is decreasing if v and t and a of t are different signs. So this is going to be pretty difficult, I'd say, just remembering all this stuff, but I relatively doubt that it will be on whatever quiz or test you're taking, but just prepare yourself for everything. Okay, let's zoom out a little bit here. We have an equation with a table, so it's going to be bad. The amount of water in a tank in gallons can be modeled by the function v of t, where t is measured in hours. Selected values of v of t are shown in the table below. Approximate value of 1 over 18, crowbar 18.0 v of t dt, using, this is approximately, this is approximate, not approximately. Approximate the value of 1 over 18, crowbar 18, bottom 0, v of t dt, using midpoint Riemann sum with 3 subintervals. So basically what it's saying is find the average value of v of t from 18 to 0. So if you ever did a midpoint Riemann sum, or any Riemann sum for that matter, this might seem a little bit familiar. It's just the same thing, plug and play, right? So I have my 1 over 18, and then I have 6 v of 3 plus 6 v of 9 plus 6 v of 15. That's if we just factor this out, right? 6, 6, 6. You can cross that out, so it's actually just 1 over 3. So now I have my values, 36, 39, 36. I'm adding those together, dividing that by 3. You get 111 divided by 3, and that's 37 gallons. So that's how you'd end up doing that equation. If you're confused about the context as to why it's like this, the amount of water in a tank in gallons can be modeled by the function v of t, where t is measured in hours. So basically saying how much water we have in the tank over hours. Because we're going back, right? The whole thing about integrals is that we're going back. That means that we're taking away the hours part, right? So whenever you're doing a derivative, you're adding an extra hours. So it might be, instead of miles per hour, if you're deriving that, it would be miles per hour, or miles per hour squared. It's the opposite with integrals. So instead of it being miles per hour, it would be miles, like total, like how much distance you had, for example. Okay. Next. This one's a bit of a calculator question again. During time interval 5 is less than or equal to t, which is less than or equal to 17. The rate at which the depth of snow on the ground is changing in centimeters per week can be modeled by the function f of t is equal to negative cosine, parentheses 0.04 t squared, close parenthesis, plus 1, which is a bit of a mouthful, and it's going to be even worse when you type it in your calculator. Where t is measured in weeks at time t equals 5. There's a depth of 5 snow on the ground. Determine the value of crowbar 17.5 f of t dt. So, what this is asking us is to take this thing right here, move it over here, put it in your calculator. That's literally all it is. So let's actually, in fact, do that so you guys can follow along with me and you get that practice of doing it. 5 at the bottom of the crowbar, 17 at the top of the crowbar. -2 cosine 0.04. Can you see that? Yep, 0.04 x squared, close parenthesis. Remember the +1. The first time I did this, I actually got this question wrong because I forgot about that +1 right there. So do not forget it. Okay, you have to really remember that just because it's a mouthful doesn't mean that you can just skip something, okay? Because you'll get completely different answers. So I have this right here. It's a dx, of course, and I just press enter, and yep, same thing. 16.0477, which I can round to 16.048 centimeters. So let's talk about that context again. The depth of snow on the ground is changing in centimeters per week, right? Because we're integraling it, we're taking away 1 week. So let's imagine a hypothetical where instead of it asking us for f of t, it's asking for the integral of f prime of t. So we're getting snow on the ground per week, and then we're integraling that. Or, yeah, we're finding the integral of that. We would be taking away 1 week, which means we would be taking away the week that we just added, which I know is confusing, but basically what I'm saying is that just remember the fact that if you're deriving something, you're adding the per, and if you're doing an integral, you're removing the per, okay? So per hour, you're adding that, another one of those, with deriving stuff. And with integrals, you're removing that that per hour, that per week, that per day, that per some time frame, some x value, or x value, some like input, your x-axis, you know? So that's just about it when it comes to average values for AP Calculus. I wish you the best of luck on your quiz.